We're going to be talking today about section 11.2, which is events involving not and or. We're going to be talking about some properties of probability, events that involve not, and events that involve or. So first of all, when we're talking about probability, probably the most important thing to think about is that with probability, the probability of something always has to be some number between and including 0 and 1. So you can't have a probability less than 0, and you can't have a probability greater than 1. So the probability of something happening that's impossible would be 0. And the probability of an event definitely occurring would be a 1. So that's what they mean by the probabilities have to be between and including 0 to 1. So here's what we're talking about. When a single dice is rolled, find the probability for each event. So the number 3 is rolled. So if you think about the face of a die, the 3 only occurs one time. If I roll my die one time, then there is a 1 in 6 chance that I will obtain a 3 on the face of my die. So the probability of the number 6 being rolled would be 1 out of 6 as a probability. Remember, when we're doing probability, we always want to take the favorable outcome divided by all the possible outcomes. So again, with a dice, there are 6 possible outcomes, and the one that I want is a 3. So if the probability of getting a 3 is 1 out of 6, then the probability that I don't get a 3 would be all the other faces of the die, which are 5 faces out of 6 possibilities. So the probability that I would not get a 3 would be 5 out of 6. The probability that a number 7 is rolled. Well, 7 is not one of the possible faces on a die, so the probability of that happening is 0. Okay, a number less than 7 is rolled. Well, if you think about all the numbers on the face of the die from 1 to 6, they're all less than 7. So the probability that I'm going to roll a number less than 7 is guaranteed. So it would be 1. And that's what this is talking about here. Again, the faces of the die are the numbers 1 through 6. So the probability of a 3 would be 1/6. The probability of not getting a 3 would be 5/6. The probability of 7 is 0, and the probability of less than 7 would be 1. So we've looked at this table that I'm going to show you next, but we're going to be talking a little bit more about what they mean by the complement and subtraction and things like that. So here we have again this table, which should look familiar. And again, with set theory, we talked about the complement as the apostrophe. We talked about with logic, the tilde is not. And subtraction is the arithmetic operation for not or the complement. And with the union or the or statement, it was addition. And for the intersection or the and symbol, it was multiplication. And so we're going to be using that a little bit more today. Okay, so the probability that something will not occur is the same as the probability of 1 or the number 1 minus the probability that it will occur. So again, if I think about flipping a die, flipping a coin. If I flip the coin, the probability that I can flip a head is 1/2. Well, the probability that I could flip a tail, which is the other choice, is also 1/2, or 1 minus the first 1/2. Think about a dice. The probability of rolling a 3 is 1/6. The probability of rolling anything else except for a 3 is 5/6. So if you go back to that slide and look at it, 1/6 plus 5/6 equals 1. So what we're talking about here is, again, the probability of an event that will not occur is the same thing as saying 1 minus the probability that it will occur. And you can also think of the inverse of that. 1 minus the probability that it will not occur is the probability that it will occur. So we're looking at a couple of, the main formula that you need to be familiar with here is the probability of some event plus the probability of the complement of that event, or the probability that it will not occur, is equal to 1. Okay, so a single card is drawn from a standard 52 deck of cards. What is the probability that it will not be an ace? So again, what we want to look at is if we can figure out the probability that it will be an ace, then if we subtract 1 from that, or 1 minus that, we will know the probability that it will not be an ace. So remember that there are 4 aces in a deck of cards. So the probability that we draw an ace is equal to 4 chances out of 52. Because again, there are 4 aces in a deck, and there are 52 cards in a deck of cards, so the probability that it is an ace is 4 out of 52. So the probability, I'm going to use a little bit of symbolism here, that it's not an ace would equal 1 minus 4 out of 52. And in order to subtract that, of course, you've got to have a common denominator, so it would be 52 over 52 minus 4 over 52. So the probability that it's not an ace is 48 out of 52. And then we always want to reduce our fractions, so that reduced would be 12 out of 13. So the probability that we do not draw an ace would be 12 out of 13. And here's some of that math again. Now you could have probably figured this out without having to go through this formula, because if you think about a deck of cards, if there are 52 cards in the deck and 4 of them are aces, then I don't want an ace, so that means there are 48 cards left over. So 48 out of 52 does make sense, but the formula will help you as we get further into this material. Okay. So the probability of one event or another event is what we call the union, and that, for union, we always use addition. So let's look at an example with union. So if one number is selected randomly from the set, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, find the probability that would be an even number or a multiple of 7. Okay, so even numbers would be, call that E, probability of even. The even set is 2, 4, 6, 8, and 10. So I have 5 chances to get an even number out of 10 possibilities. So it would be 5 out of 10. So the probability of an even is 5 out of 10. The probability of a 7, well, there's only one number or one set that has a 7 in it, so the probability of drawing a 7 would be 1 out of 10. So when we add those two together, the probability of an even number or a 7 would be 6 out of 10, which reduced is 3 out of 5. So that's what we're talking about here. The probability of even is 2, 4, 6, 8, 10. The probability of a 7 is 1/10. So the probability of an even number or a 7 would be 6 out of 10. Okay, let's look at another one that's similar to that. This time I want the probability that would be even or a multiple of 5. So if we look at our possibilities here, even are 2, 4, 6, 8, 10 again. Multiple of 5 is 5 and 10. So when we're counting the probability of multiples of 5 or even, we don't want to count duplicates in there. So since the 10 is in both sets, or in both, in both sets, we don't want to count it twice. So again, we're still only dealing with a probability of 6 over 10, which is 3/5. So when two events, A and B, are mutually exclusive events, that means they don't have any outcomes in common. So they can't occur simultaneously. So that's just what we mean by mutually exclusive. So let's look at some of these rules that we were talking about. And these, again, should look fairly familiar. Remember, again, when we're talking about A or B, and the events are not mutually exclusive, then we have to take away that overlap. So example, again, was the even and multiple of 10. We had to deduct that overlap of the number 10, we had to deduct that overlap that we had in both sets. But if I had the first example where I had multiples of 2, or I had even numbers and multiples of 7, then I didn't have to deduct anything because they were mutually exclusive. So that's where I just added the two probabilities together. Okay, so let me write that just to make sure. So this was the example of even numbers and multiples of 7. Again, they didn't have anything in common. But this one was the example where we did even numbers and multiples of 10, I'm sorry, multiples of 5. And again, they had that overlap on the previous example where they had that one thing in common. Okay, so here's another example. You have a single card drawn from a standard 52 deck of cards. What's the probability that it will be a king or it will be a diamond? So the probabilities of kings are 4 cards out of 52. The probability that it is a diamond would be 13 cards out of 52. Okay, now in this situation, you could have a king of diamond. So there is an overlap. It is not mutually exclusive. So we have to take away that one overlap situation where we have the king of diamonds. Because I have counted that in with the set of kings and with the set of diamonds. So our formula to find the probability would be the probability that it is a king plus the probability that it is a diamond minus that overlap of the king of diamonds. And so what we end up with is that the probability that this happens is 16 over 52, which reduces down to 4 over 13. So again, the probability of the king plus the probability of the diamond minus the probability of the king and the diamond overlap. Okay, so let's look at one more example. A single die is rolled. What is the probability of a 2 or an odd? Okay, so with the roll of a die, the probability of a 2 is 1/6. The probability of an odd number equals 1, 3, or 5. So it would be 3 out of 6. Now 2 is not an odd number, so there is no overlap. So the probability of a 2 or an odd number equals 4/6, which reduces to 2/3. I hope this helps. Again, keep up with your homework. Give me calls or emails or text if you're having problems. And be prepared that we will be having a test coming up soon. Have a great week.